Assalamualaikum and hi everyone. So today we will be talking about radio wave based on imaging. Without further ado, let's get started. But before we start, I would like to introduce our group members. My name is Hani. Next we have Maisara, Mastura, Adriana, and last Fakira. First, let's start with understanding what radio wave-based imaging is. This method uses radio waves which are form of electromagnetic radiation with long wavelengths to produce image of objects, surroundings, or internal structures. Unlike X-rays, radio wave can pass through walls and the human body without causing harm since they are non-ionizing. They are especially useful in low visibility conditions and are used in MRI radar, ground penetrating radar, and radio anestroscopy.
Hi, my name is Masura Hazira and I'm going to explain about GPR. GPR, or known as ground penetrating radar, is a non-intrusive method that uses radio waves to scan beneath the ground surface. It works by sending these waves into the ground, and when they hit underground objects or layers, the waves bounce back. The system then detects those reflected waves and uses them to create a kind of picture of what's beneath. Usually it's like an X-ray, but for the soil, and using radio waves instead of radiation. Next, let me explain how GPR works step by step. First, it sends radio wave pulse into the ground. When the waves hit something like a pipe or a rock, they bounce back. A receiver then detects those reflected waves. Finally, the system uses that information to determine the depth and location of what's underground. It's a quick and safe way to investigate what's hidden below the surface. So, where is GPR usually used? GPR is very useful in construction, where it helps detect pipes or cables before digging. Archaeologists use it to locate ruins or graves without destroying the site. In forensic, it helps investigators to search for hidden objects or buried evidence. And engineers use GPRs to check the condition of roads or bridge by scanning through the concrete. GPR, a powerful tool in many industries.
Next is magnetic resonance imaging, which is MRI. So in MRI, we have role of radio waves in MRI. So MRI stands for magnetic resonance imaging, which is a non-invasive medical imaging technique that uses a strong magnetic field and radio wave to create detailed pictures of the inside of the body. This image helps doctor diagnose a wide range of conditions, from injuries to disease by visualizing organs, tissue, and other structures. So the first one is the first role of radio wave MRI is used to excite hydrogen protons in the body. MRI mainly looks at hydrogen atoms in the body which are found in water and fat. Radio waves are used to excite these hydrogen protons. Second, radio frequency pulse causes protons to absorb energy and misalign. The machine sends a short of burst of radio frequency wave called a RF pulse, which is give the protons energy and knocks them out of alignment with the magnetic field. Third, when RF stops, protons release energy as signals. When the RF pulse is turned off, the proton relax and go back to their original position. As they do this, they release the energy they absorbed. For MRI machines detects these signals. This released energy comes out as a radio signal which is picked by the MRI scanner. Fifth, signals are processed to form detailed body images. The signals are sent to a computer which processes them to create detailed image of the inside of the body. Last, safe, non-invasive, and radiation-free. One big advantage of MRI is that it's completely safe. It does not use any harmful radiation like X-ray or CT scans.
Security scanners called millimeter wave scanners use radio wave to check people. These waves are very short and they bounce off your body and clothes. When the wave hits something hidden, they bounce back in a different way. The scanners use this to find objects under clothes. Millimeter wave scanners use safe radio wave like the one from your phone or Wi-Fi. These waves do not cause any harm to your body. That means the scanner is safe for all people, including children and pregnant women. You only need to stand still for a few seconds and the machine does not touch you. This makes the scanner quick, easy, and safe to use. Millimeter wave scanners are used in many big airports around the world like Heathrow in the UK, JFK in the USA, and Dubai Airport. These scanners can find hidden items under clothes, such as knives, guns, liquids, gels, and even plastic explosives. By detecting these dangerous things before people get on planes, the scanners help keep everyone safe during air travel. Older scanners used to show clear body shapes, which made some people feel uncomfortable. But now, new millimeter wave scanners protect your privacy. They do not show your real body, instead, they show a simple cartoon like image that looks the same for everyone. If nothing dangerous is found, the screen just shows OK. This way, security can still check for hidden items while keeping your privacy safe.
In this slide, it shows three technologies that use wave to help us see hidden things. The first one is ground penetration radar, is used to detect objects underground, like in archaeology or for finding buried cable. The second one is MRI or magnetic resonance imaging, using magnetic field and radio wave to create detailed image of the inside of the body for medical check. And the third one is millimeter wave scanner are used in places like airport to scan for hidden items on people without touching them or using harmful radiation. So in summary, all three of these technology use different type of wave to help us see things we normally can't, whether it's underground, inside the body, or hidden on person. Now, let's look at comparison between GPR, MRI, and millimeter wave scanner. First, GPR is mainly used for underground imaging. It uses low-frequency radio wave and can detect objects several meters below the ground. The image quality is moderate. Second is MRI is for medical diagnostic. It uses both radio wave and magnetic field to scan inside the body, giving high resolution image. And the last one is millimeter wave scanner are used for security like at airport. They use high frequency wave to scan through clothing and their image resolution is moderate. Each tool has its own strength depending on what and where we are trying to see. These slides show the future direction of radio wave imaging. First, we can expect higher resolution imaging, which means clearer and more detailed image. Second, portable and wearable image device will allow easier use in different locations, even on the go. And lastly, these technologies can help in environmental and structural monitoring, such as checking building or natural areas for damage and change. Overall, radio wave imaging is become more advanced, mobile, and useful in many fields.